What is the Advanced Oxidation Process, AOP? The Advanced Oxidation Process, AOP, is a chemical treatment designed to remove organic and sometimes inorganic matter in water by reactions with hydroxyl radicals. It enhances the decomposition of ozone into hydroxyl radicals and using hydrogen peroxide, producing radicals faster than standard zone decomposition. The process combines ozone and UV into one system to maximize disinfection, water clarity, and chloramine removal. It involves the generation of hydroxyl radicals to purify water using a combination of ozone, hydrogen peroxide, and/or ultraviolet light. Is AOP a new technology? No, AOP is not a new technology. Oxidation processes involving hydroxyl radicals have been in use since the 19th century. However, large-scale water treatment using these radicals didn't occur until 1987. Today, there are approximately 500 commercial AOP installations worldwide for drinking water. How does AOP work? The destruction of organisms and contaminants occurs in the AOP chamber within a few inches of the injection point. As a result, many AOP devices must operate 24 hours a day. However, this does not guarantee safe water, especially if a biofilm develops on the pool walls or in the plumbing system. How are hydroxyl radicals introduced into pool water? Hydroxyl radicals are introduced into pool water through an AOP device similar to an electronic chlorine generator ECG or ozonator installed in the plumbing line. The device can be in line with full flow or a side stream in commercial or public pools. In the side stream, about 25% of the full flow is diverted through the AOP device. These devices often have a contact chamber to maximize hydroxyl radical contact with contaminants. How is AOP used in water treatment? AOP is used in water treatment as a highly reactive and fast method for effectively removing taste, odor, and organic micropollutants that are difficult to remove within ozonation alone. In some AOP, H2O2 is fed as an aqueous solution with H2O2 to ozone ratios between 0.2 and 3. The optimal ratio for removing most compounds ranges from 0.3 to 0.6. Both ozone and AOP processes form bromate in the presence of bromide, which is carcinogenic. How does AOP compare to ozone and UV? AOP is the most potent oxidizer for pool or spa water, covering almost all oxidizable substances in the water and serving as an excellent disinfectant compared to UV, which effectively destroys viruses, bacteria, and pathogens, but only affects water passing through the UV light chamber. AOP has a broader range of impact. However, the hydroxyl radicals in AOP have a very short lifespan, making it less likely to be used as a standalone disinfectant and oxidizers. On the other hand, ozone is excellent at destroying viruses, bacteria, taste, odor, chloramines, combined chloride, and most organic matter, but it reacts slowly with ammonia and doesn't cover all oxidizable substances in the water. It also has a short half-life in pool water and doesn't provide a lasting residual. Therefore, while AOP, ozone, and UV each have their strengths, they also have limitations and are often used in combination for optimal results. Can chlorine be completely eliminated using an AOP device? No, chlorine cannot be completely eliminated using an AOP device. While UV, ozone, and hydroxyl radicals are powerful oxidizers and disinfectants, they do not build up in the water or protect against future contamination. They produce a fixed amount of hydroxyl radicals, which may not be sufficient for increased demand. What is the efficiency of OH-AOP in oxidizing water? The efficiency of OH-AOP in oxidizing water is not explicitly stated in the provided information. However, it is mentioned that OH-AOP, which produces hydroxyl radicals, is a more potent and efficient oxidizer than hypochlorite ion, hypochlorous acid, ultraviolet light, or ozone. Hydroxyl radicals are highly reactive and unstable, allowing them to react non-selectively with dissolve solids, and decompose harmful substances into less harmful ones, or even completely mineralize them. They can destroy various contaminants and microorganisms. However, their short half-life makes it impossible to build up a residual or measure it practically. The efficiency of the AOP process can be attracted by factors such as total alkalinity in the water, with the process being less efficient at higher alkalinity levels. The yield of hydroxyl radicals can be significantly improved in the presence of other oxidants or irradiation. Why is AOP gaining popularity? AOP is gaining popularity as water shortages and droughts force water treatment facilities to explore alternative water sources and consider wastewater recycling. The Advanced Oxidation Process, AOP, is a recent advancement in oxidation that combines ozone and UV into one system, maximizing disinfection, water clarity, and chloramine removal. It is highly reactive and fast, effectively removing taste, odor, and organic micropollutants that are difficult to remove with ozonation alone. AOP is also used for the destruction of organic or inorganic contaminants in water, despite its limitations such as its short half-life and lack of lasting or measurable residue in the water. AOP is becoming an increasingly popular choice in water treatment. What are the pros of AOP devices? The pros of AOP devices include their ability to kill organisms like Cryptosporidium parvum and Giardia lamblia, destroying combined chlorine, chloramine, oxidation byproducts, organics, microorganisms, and microcontaminants. They are more powerful than chlorine and do not add lasting chemicals to the water. AOP devices can reduce chlorine consumption by 50 to 90% depending on the device and conditions, and they provide better water quality. What are the cons of AOP devices? The cons of AOP devices include the fact that the hydroxyl radicals last for 10 microseconds or less. They provide no residual in the water, and there's no way to verify optimum level operation. All oxidation and killing is done in the AOP device, so there's no control of biofilm or algae. They provide a fixed amount of ozone, UV, hydrogen peroxide, and hydroxyl radicals, which may not be adequate when water loads are high. They may not provide protection against future introduction of pathogens or person-to-person contact. Sometimes they are sold as chlorine-free but are not approved for that use. There's no test for hydroxyl radicals or AOP, and no AOP or hydroxyl radical dose guidelines or approvals. Their efficiency is affected by high humidity, temperature, high pH, high alkalinity, iron, copper, and manganese. The UV protective quartz sleeve need frequent cleaning, replacement, or consumable parts availability and cost can be an issue, and they are expensive. How to choose the right AOP device? Choosing the right AOP device can be challenging. In the early 1990s, the ozone segment of our industry faced a similar issue with dosing and sizing. Manufacturers claim different output amounts using various testing methods, leading to confusion. Eventually, they agreed on a standard test method and dose amounts, making it easier for customers to compare products. What are the challenges with AOP dose and output amounts? The dose level of AOP and the output of the device pose significant challenges for AOP manufacturers. These challenges arise due to the lack of standard output test methods and hydroxyl radical dose level criteria. Until AOP manufacturers agree on these standards, the industry and potential clients will suffer. How to determine if AOP is working? Determining if an AOP device is working isn't straightforward. The units have a light or sight glass to check if the UV bulbs are on. However, this doesn't guarantee the production of ozone, UV, hydrogen peroxide, or hydroxyl radicals. The only way to assess if an AOP device is working is to measure the chloramines or combined chlorine and see if adding AOP lowers or eliminates them. What are the claims of AOP manufacturers? AOP manufacturers claim that their device can reduce chlorine used by 30 to 90% or even eliminate it completely. They also claim to eliminate chloramines, improve water quality, and destroy harmful organisms like Cryptosporidium, Giardia, or E. coli. However, they note that in the event of a fecal accident, there is no way to determine when the water will be safe again. They also acknowledge that while there are NSF certification standards or ozone or UV, there are currently no standards for AOP. What is the cost of residential AOP devices? Residential pool AOP devices typically cost between $1,000 and $300. Spa AOP units are less expensive.